Well, good afternoon. Today we are going to look at some properties of logarithms. We're going to solve some log equations, and then we're going to look at domain and range when it comes to logarithms. So to get started, here are our product properties, our quotient property, and our power property of logarithms. So looking at this first case scenario here, we have log base b of m times n. There's a multiplication symbol in there, it's just understood. So we have those two terms here, m and n being multiplied together. In order to expand this, we're going to separate the m and the n into two separate logs. Keep in mind that the base here has stayed the same. So log base b and log base b, we've just duplicated. And then there's addition here in the middle. So we've separated the two terms that were being multiplied into two separate logarithms using addition in between them. For our quotient property here is when we have division. So I like to tell my students that this division bar looks a lot like the subtraction sign. So when we expand from division to subtraction, we're going to use those two symbols just kind of in a different manner. So log base b of m divided by n actually converts to log base b of m minus log base b of n. And in this case, order matters. The numerator must come in the first log. The denominator must come over here in the second log where that n is. The last property is the power property. So here we have an exponent of an x. Anytime we have an exponent, it is allowed to get brought down out front like this x is right here. So that is the power property. And then keep in mind that all of these properties can be used in either direction. And we're going to practice actually both of those on the coming slides. But note that if I were looking at this term here, that x could also be moved up to become an exponent using the power property. So here are some examples. The first two examples up at the top are going to be the product property. So we're going to condense. Anytime it tells me to condense, I'm going to take multiple logs and I'm going to put them together. My objective is to end up with only one logarithm in my answer. So for this first one here, we have log base 7 of 2 plus log base 7 of 4. So when I condense those, I'm going to have log base 7 as my log. My base, again, always stays the same. And then I need to look at the symbol right here in the middle to determine what operation I need to use for the 4 and the 2. So since that operation is addition, addition leads me to the product property. So I'm going to take 2 times 4. And for these properties, for some reason, Ivy Tech doesn't care if you multiply them together to get 8. They will accept answers of 4 times 2 right there. So that would be your final answer when you condense those two logarithms into one. For the logarithms on the right-hand side here, still the product property. We know that because there's addition signs here. Now we have 3 logarithms that we're going to condense into one. You can do it in a couple different steps, or you can do it in one step if all of the signs are the same. So here we have 2 addition signs. So we're going to use the product property 2 different times. starting out with our log base 2. They're all log base 2, so we're going to condense them to be all log base 2 in one logarithm. And then now the three terms here, here, and here are all going to get multiplied together inside my parentheses. So 5 times 6 times x. And like I said in the last problem, it's not required of you to actually multiply this out to get 30x. Ivy Tech is okay with you leaving it as 5 times 6 times x, just like this. So this would be finished. This is your final answer. So we've condensed 3 logarithms down into one using that product property to do so. Looking at the section in the middle, first thing I notice here is that we have, subtraction signs. So we have a subtraction sign there. Since that is a subtraction sign, I know that I'm going to use the quotient property. When we use the quotient property, we're going to keep the log and we're going to keep the base. When I keep the log and I keep the base, I then am going to use the quotient property because it's subtraction. So I know I'm going to create a fraction in my parentheses. And then the first term is going to go to the numerator. So the 12 goes to the top and the 4 goes to the bottom. And the same thing's true about these as the last problems. You don't need to go ahead and simplify that. You can leave this as your final answer. So take a minute and see if you can do the next one. So see if you can take log base 3 of 7 minus log base 3 of y and combine them into one single logarithm using the quotient property. So again, we know this is a quotient property problem because when we look at the problem, we see this subtraction sign right here. That subtraction sign is always associated with the quotient property. So we're going to combine log base 3, and then I'm going to have some sort of fraction in my parentheses. The first logarithm has to go to the top. So the 7 goes to the numerator. The y goes to the denominator. So log base 3 of 7 over y is our final condensed answer. Moving on to the bottom section here, we're going to look at the power property. So the power property occurs when you either have an exponent or you have a number sitting in front of a logarithm. So in this case, on this problem, we have a 2 sitting out front of the logarithm. That's going to get moved up to become an exponent up here. So in this case, we have a common log. So log base 10, since there's no number written there, remember it's 10. The 4 stays where it's at, and then the 2 becomes an exponent attached to that 4. So log of 4 squared. So when we're condensing, we're moving numbers that are out front of logarithms up to exponents, making them just a tad bit smaller to condense them. So try the one over here on the right hand side, 3 log base 6 of x. So for this one, we're going to take that 3 and we're going to move it up to be an exponent with the x. So we're going to have log base 6 of x to the 3rd power. And that is completely condensed. So now we've practiced each of the properties individually. So we started out with the product property for the first 2, then we moved to the quotient property in the middle, and then the power property down there at the bottom. And now on the next slide, we're going to use multiple properties in one problem. So if we look at the first example, we have 5 log x minus log 4. So when I look at this one, I notice this 5 sitting out front. I also notice the minus sign here in the middle. So those 2 things lead me to condense using both the power property and the quotient property. So I'm going to simplify the power property first. This 5 is going to get brought up only to the log that it's attached to. So log of x to the 5th minus log 4. So that's our first step. We're going to use that power property to move that 5 from in front of the logarithm up into the position of an exponent, just with that logarithm that it's attached to. So we didn't do anything with the minus log 4 yet. Now I'm down to 2 logarithms with a minus sign in the middle. The minus sign leads me to the quotient property. So the quotient property says, hey, you're going to take a log of some sort of fraction. In this case, the order matters. X to the 5th must go on top of the fraction, and 4 must go down to the bottom in the denominator. And then this right here is my final answer. So we have a common log of x to the 5th over 4. Jumping over to the next example, we have 3 times log base 8 of n plus 2 log base 8 of m. So some things that stand out to me and hopefully stand out to you, we have the 3 out front, we have the 2 out front of the log, and we have an addition sign in the middle. So those are going to lead me towards the product property and 2 of the power properties. So we always want to look at the power property first. So the 3 is going to get moved up to the n. The 2 is going to get moved up to the m. So we're going to have log base 8 of n to the 3rd power plus log base 8 of m squared, or to the 2nd power. So that's our first step to condense these. My next step is going to be to condense these because they're addition. We're going to use the product property. So the product property is telling me that I'm going to multiply this times this. So I'm going to put 1 log and then I'm going to multiply n to the 3rd times m squared in parentheses. So log base 8 of n to the 3rd times m squared. And that is our final answer. We condensed 2 logarithms into 1 logarithm. For this last example here, we are going to actually use all 3 of the properties. So we're going to start out with the power property. Automatically, we want to start with the power property. So in this case, we only have 1 here with the 3. So the 3's got to get moved first. So we're going to have log of 2 to the third plus log 4 minus log 16. That is our first step. We're going to get rid of the number sitting in front of the log using the power property to move it. And then since there's no parentheses or anything here, we're just going to start combining from left to right. So I'm going to combine these two logarithms first. Between those two logarithms is addition. So I'm going to use the product property. So I'm going to have a log of 2 to the third power times 4. We haven't done anything with that minus log 16 yet, so we're going to bring it down. Next thing we need to do to combine these two logarithms, so we've gone from 3 logs to 2. These two are attached together with a subtraction sign here. So that subtraction sign leads me to the quotient property. So I'm going to have to go over here because I ran out of room. But we're going to have 1 log. And then we're going to have, since the quotient property was the one we selected, we're going to have division. Whatever's in parentheses for the first log gets brought up. So 2 to the third times 4 goes to the numerator. 16 goes to the denominator. And this right here is our final answer. So I highly suggest that you work through these problems in steps. I've had students in the past who want to do everything all at once and then they get confused in the middle or they leave parts out. So I'll always suggest that you do the power property first automatically and then go working from left to right unless you have parentheses. And we have a critical thinking question at the bottom. Can we write 3 log base 2 of 9 minus log base 6 of 9 as a single logarithm? So when I look at these two problems, the first thing that stands out to me is that one of them is a base of 2 and the other one is a base of 6. So we cannot write these as one single logarithm because they have different bases. So all the problems that we've done so far have always had the same base. So in order to combine them, they must have the same base because you're writing them into one logarithm. And in this case, you wouldn't know what base to use because you have a base of 2 as well as a base of 6. All right, next thing we're going to do is the opposite of what we have been doing. So we've been condensing and now we're going to expand. So we're going to have to identify now whether we have multiplication, division, and exponents in order to expand them into addition, subtraction, and then that number in front of your logarithm. So looking at example A, we have a division problem. Since it's division, we're going to separate it using the quotient property. So we're going to have log base 5 of something minus log base 5 of something else. So our task now is to figure out where the x goes and where the y goes. Remember, for the quotient property, order matters. The x must be in the first set of parentheses, the y must be in the second set. And you will see this sometimes without the parentheses because it's just x and y. So be mindful that sometimes they'll have the parentheses and sometimes they won't. Going over to letter B. When I look at letter B, I know there's multiplication between the 3 and the r to the 4th. So we're going to have to separate those two using the product property. So we're going to have log base 10 of 3 plus log base 10 of r to the 4th power. This one, however, is not finished. So remember how previously we worked on the power properties first. We're going to do the power properties last in this case. So we're going to move that exponent. So this exponent is going to get moved in front of the logarithm that it's attached to. So the log of 3 isn't going to change. The plus sign comes down, and then we're going to have 4 log r. And then this is our final answer. So there's no exponents left, there's no multiplication left, and there's no division. All right, looking at these next two, they're getting a little bit more complicated as we go. So now we have log base 9 of c to the 3rd times the cube root of a. So I notice that this is a multiplication problem. There's multiplication right there. So we're going to have to use the product property to expand these. When we expand, we're going to use addition. So log base 9 of c to the 3rd plus log base 9 of the cube root of a. So once we do that, we're down to just the power property. We got rid of all the multiplication and the division. So it's fairly easy to see that this 3 is an exponent and it should get brought down out front. So that should become 3 log base 9 of c. However, if you remember from algebra 2, I'm going to go here. The cube root of a can be converted to an rational exponent. So that is the cube root of a to the 1st, which can be rewritten as a to the 1/3 power. So we could rewrite this as log base 9 of a to the 1/3 power. Well, now it's easier to see that we have another exponent that we need to deal with. So now we need to take that 1/3 power and it's going to move down in front of that second log. So 3 log base 9 of c plus 1/3 log base 9 of a. So that's a little trick that IB Tech will try to sneak in on you on your final exam. So remember, anything with a radical can be rewritten as an exponent, which then can get brought down in front of your logarithms. So if it was a square root, you would have 1/2 as the exponent. If it was a 4th root, 1/4. And so on there. All right, the hardest one. So here we've got all sorts of properties being put together. So we're going to start off with the fraction here. The fraction tells us that we need to use the quotient property to separate the numerator from the denominator. So I'm going to separate this into log base 2 of x to the 5th times the cube root of y minus log base 2 of 4. So now looking at this term here, I see multiplication. That tells me that I need to separate this first logarithm into two new logarithms. So log base 2 of x to the 5th plus, because it's multiplication, we're going to use the product property, log base 2 of the cube root of y minus log base 2 of 4. We're getting closer. We've eliminated all of the multiplication and division. Now we need to look at all of our powers. So the first one's easy to see. We have that 5 sitting with the x as an exponent. It's going to come down and become 5 log base 2 of x. Remember, we talked earlier, anytime you have, in this case, a cube root, that cube can be replaced with 1/3 as an exponent. So that 1/3 is going to come down, log base 2 of y. So if we wanted to, we could have written it right here as y to the 1/3 power instead of the cube root of y. Minus, another trick that Ivy Tech is trying to pull on you here, we have log base 2 of 4. Notice there are no variables in that. Since there are no variables, they want you to actually compute log base 2 of 4. So in your calculator, you're going to use the change of base formula. Change of base formula that we learned yesterday says, hey, take the log of the numerator divided by the log of the denominator. So in your calculators, you're going to take log 4 divided by log 2, and it's going to work out really nicely for you. And it's just going to give you 2. Thankfully, the question on the Ivy Tech final that deals with this is actually multiple choice. So when you get to your answer and you think it's still log base 2 of 4, it's not even going to be an option. So hopefully that leads you to using the change of base formula to get your final answer. So that's expanding and condensing logarithms. The next thing we're going to do is looking at solving logarithmic equations. So when we solve logarithmic equations, we have 2 steps. We're going to rewrite it in exponential form, and then we're going to solve what remains. So if you remember from yesterday, the first thing we want to do is label the pieces. So this, whoops, not highlighter. So here is my base. Here is my y term, and here is my x term. And then we want to rewrite it as b to the x power equals y. So b to the x power equals y. If we do that, we're going to have 2 to the 4th power equals 2x. When I look at this now, I have 2 as an exponent with the 4, so I'm going to take 4 to the 2nd power. Well, 4 to the 2nd power is 4 times 4, which is 16. In order to solve this, I'm going to divide both sides by 2, and x equals 8. And that would be it. So we only got one answer. There's no real reason to check that one. So we're going to leave it as x equals 8. We're going to repeat the same process for the question on the right-hand side. So I'll give you a minute to see if you can label those parts, rewrite it in exponential form, and then solve the remaining equation. So for this one, hopefully you rewrote this as 9 squared equals 4x plus 1, or 4x plus 1 equals 9 squared. Either way there. Then you're going to take 9 and square it. 9 squared is 81. Subtract 1 from both sides. That's going to give you 4x equals 80. And then you're going to divide both sides by 4 to get a final answer of x equals 20. In order to make that a little bit more challenging, we're going to throw in the properties of logs. So before we can rewrite these problems in exponential form, we have to combine them using the properties of logs. So for this question here on the left-hand side, it's an addition problem. So we're going to combine both of these using the product property. Just like that. So we're going to combine 8 times x so you can never rewrite in exponential form if you have more than one logarithm. So you've got to combine first. So now that I've combined these, I want to write these in exponential form, but when I go to write b here, there's no base written. So remember, if there's no base that's being identified, it's the common log, which has a base of 10. So b in this case is 10, x is 1, and y is 8 times x. So I'm going to rewrite this as 10 to the first power equals 8 times x. And I'm going to solve for x. So 10 to the first power is just 10. 8 times x is just 8x. So really all I have is 10 equals 8x. I'm going to divide both sides by 8 to get x equals 10 over 8, which reduces to 5/4. Due to time constraints, we're going to skip this problem and work on the next one. So this one's really important. There's a question similar to this one on your final exam. So you've got to know how to do this one. So just like the last one, it is 2 logs on the left-hand side combined with an addition sign in the middle. So to combine these two into 1 log, we need to multiply the x minus 5 times the x plus 3. This itself is actually a box problem. So we need to box x minus 5 times x plus 3. So I'm going to go off to the side and we're going to multiply those together. So x times x is x squared. X times negative 5x is negative 5x. 3 times x is 3x. And negative 5 times 3 is negative 15. So that's going to give me x squared minus 2x minus 15 in my parentheses there. So now that we've combined those two sets of parentheses using our box, getting that x squared minus 2x minus 15, we only have 1 logarithm on the left-hand side. So we can identify our parts. So this is b, this is x, this whole set of parentheses is y. So we're going to have 3 squared equals x squared minus 2x minus 15. Now, if I had just given you this problem over here on the right-hand side and told you to solve that equation, hopefully you would identify, hey, it's a quadratic, it has x squared in it. So I want to move everything to one side so that I can factor. So we're going to take that 3 squared, which is 9, and move it to the left or the right hand side. We're going to subtract 9 from both sides. So that's going to give me 0 now, equals x squared minus 2x minus 24. So now we have a quadratic, we've got 0 on one side. We want to go ahead and factor. If I factor this using the asterisk, I'm going to have 1, 1, negative 2, and negative 24. So 2 numbers that multiply to give us negative 24, but add to give us negative 2. Going to be negative 6 and positive 4. That being said, we're now going to have 2 factors. They're going to be x minus 6 and x plus 4. To go ahead and solve, we're going to set both of those equal to 0 to get x equals 6 and x equals negative 4. Now, this is the first example where we've had a logarithm where we've ended up with two answers. Since we ended up with two answers, we need to check them. So when you check these, the shortcut to check them is just to make sure that whenever you plug in, the parentheses must always be positive. So if I take 6 and I plug it into both sets of parentheses, I would take 6 minus 5 and then 6 plus 3. Well, 6 minus 5 is 1. 1 is positive, so we're good. 6 plus 3 is 9. 9 is positive, so that one works as well. So 6 is going to be an answer. However, if I take this same problem and I plug in -4, -4 minus 5 is going to be a negative number. So it's going to be -9. If you would type log of -9 in your calculator, it's going to give you an error message. Same way with -4 minus 3 is going to give you -1, not allowed in either case. So x equals -4 is actually extraneous. So it does not work. So anytime you end up with two answers, you just want to check them in the original equation. You could try to plug them in the entire equation and work your way through the whole thing. But like I said, if you just plug those into those parentheses and you get a negative number, you can stop because it's not going to be a solution. The last thing for today is fairly easy. Easy for me to say that though. So domain and range of logarithms. So here's a couple graphs of a couple different logarithms. Your domain for a log base A of x, whatever is in this position here must be greater than 0. So that's whatever we have for our problem. We're going to take whatever's in those parentheses, set it greater than 0, and then solve for x if necessary. For our range, the range for every single logarithm, every single logarithm is going to have a range of all real numbers. And Ivy Tech wants you to indicate that with -infinity to +infinity. So all the answers you'll get on these, you're going to write -infinity to +infinity every time for the range. So we look at this example down here at the bottom. We know that whatever's right here has to be greater than 0. So whatever goes in here must be greater than 0. Well, in order for me to solve that for x, I'm going to subtract 3 from both sides. And that's going to give me x is greater than -3. In order to write that in interval notation, we're going to say any number that's greater than -3 would be on my number line starting at -3 all the way to +infinity. So the -3 has a parenthesis, and so does the infinity, because 3 is not included, and you'll never actually reach +infinity because there's always going to be a larger number. So -3, infinity. Your range is, like I said, always going to be -infinity to +infinity for every single log problem. And then that's it for domain and range. So domain, you just set what's in the parentheses greater than 0. The range you know is all real numbers. All real numbers is -infinity to +infinity. So we've got a few for you to try. Try the first one. So I'll give you a few minutes to try the first one. So for your domain, you're going to take the 2x plus 1 and set it greater than 0. So when you take the parentheses, the 2x plus 1, set it greater than 0, you would subtract 1 from both sides to get 2x is greater than -1. Then you're going to divide both sides by 2. That'll give you x is greater than 1 negative 1/2. So for my domain, any x value that is greater than 1/2 will be a solution. So that would be numbers starting at -1/2 all the way to positive infinity because it's going greater than. My range, all real numbers, positive infinity or negative infinity to positive infinity. So that is my solution for my domain and range. Notice we didn't do anything with the base and we didn't do anything with this number hanging out at the end. Those do nothing for your problems. So those don't change anything when it comes to domain and range. This one here in the middle, we're going to take the -3x plus 9, set it greater than 0 because that's what's in the parentheses. Again, this -4 out at the end doesn't matter. We're going to solve for x. Be careful when you solve for x. First step, subtract 9, not a big deal. We're going to have -3x is greater than -9. However, remember back to algebra 1, anytime you have an inequality and you multiply or divide, in this case, by a negative number, your inequality symbol has to flip. So our inequality has to flip to less than. So we're going to end up with x is less than -3. So this time for my domain, I need any number smaller than -3. Smaller than -3 would be negative infinity to -3. So notice how that's flipped from the previous example. Because we flipped the sign, we had to flip how we wrote the domain. Your range, however, will be from negative infinity to positive infinity. This one may or may not be like the one on your final exam. So just be very cautious when you have an inequality and you multiply or divide it by a negative number. One more. So again, we're ignoring the base, we're ignoring the numbers out at the end. We just care that 3x minus 6 is greater than 0. We're going to add 6 to both sides. 3x is greater than 6. Divide by 3. And x is greater than 2. So for our domain, any number that's greater than 2 would be from the number 2 all the way to positive infinity. So 2 comma infinity. And then your range always going to be negative infinity to positive infinity. Be careful, sometimes if it's a multiple choice problem, the domain and range will be switched. They'll write the domain as all real numbers, and then the range will be what the domain should have been. So be mindful of that those are little tricks. If you're not paying close attention, you will goof on those.